All right, hello guys. I'm sorry that I'm not able to be with you today, but I thought that maybe this would be the best way for me to help you get started on your homework tonight, since we haven't done a whole lot with isotopes yet. If you remember on Friday, we watched the video that showed how isotopes are kind of like cars. You can have the same basic model of a car, but it has lots of different features to it, like whether it has a radio, whether it has heated seats, whether it has a CD player, whether it has spinners on the wheels. And that video did a really nice job kind of showing how even if something has different features, it still is the same basic model of a car. So we're going to relate that to isotopes today, and we're going to have the opportunity to look at this worksheet, which covers all different kinds of isotopic information, including how to read isotopes, how to make your own isotopic notation, and then kind of get you a little bit more familiar with the periodic table. For this worksheet, you will need to have a periodic table. It could be the one that's in the back of your book or the ones that we leave in the classroom for today, but please make sure that you return those at the end of the class period so that the rest of the classes can use those. If you don't have one, of course, we do have the one that's on the wall, and if you get home tonight and you don't have your book with you, they are everywhere online, and as long as they have the 4 basic pieces of information, the atomic mass, the atomic number, the element symbol, and the element name, you will have all of the information that you need in order to complete this worksheet. We are going to get started on it together, but then you'll have the rest of it that you'll need to finish either in class or finish up for homework that is due tomorrow. Okay? So if we look at the top here, you'll see that in this red box, I have a lot of information for you, but we're going to digest it just a little bit at a time so that you can use this to help you figure out how to do the rest of the homework. So the first thing we need to identify is what the element is looking at. So you'll notice that there are 3 different elements listed right here. They're actually all the same elements, but the way they're notated is a little bit different. And you'll notice that over here we have a key. Your key says that C is just the name of the element, which we already know, and that's carbon. A, which is whatever the top number is, whether that is 12, 13, or 14, that represents the mass number. And then Z represents the number of protons. Keep in mind that the mass number is a representation of protons and neutrons together in the nucleus of the atom. So in order to find what A equals, you can subtract the mass number minus the number of protons, and that will give you the number of neutrons. Or if you add protons plus neutrons together, that will actually give you A. Okay, so let's start by just filling out the information that we can right off the bat. The element is C, which is carbon. Okay, you need to make sure that you're following along and writing this down with me. Number 6, if you look at number 6, it is the same for the bottom number on all 3 of these isotopes. Remember, the bottom number is the number of protons that it has. Number of protons. Oh, that's not what I wanted to do here. Number of protons. This is also the number that you'll find on the periodic table. So remember, they go in order with 1 being hydrogen, 2 being helium, so on and so forth. Number 6 is carbon, so we could also say that that is this atomic number. Okay? These little squares are going to bug me. Okay? The numbers 12, 13, and 14 are referring to this top number, and that's what's different between each one of these isotopes. The top one is 12, the middle one is 13, and the bottom one is 14. That is referring to its mass number. In order to find that, we add protons plus the number of neutrons. In these pictures, if we wanted, which of course you won't always have the pictures, we could count the number of circles in each one of those, and those would tell us. Red, which are the protons, that is the same regardless. Remember, what makes an element, regardless what isotope it is how many protons it has. So carbon always has 6 protons, which means that all 3 of these are going to have 6 red circles. Okay? So if we look at D, it says how many protons and neutrons are in the first isotope. So we could count and we would know that there's 6. So we could say protons equal 6 because there's always 6 protons. Neutrons is going to equal, in this case, well, protons plus neutrons is going to be our top number. Our top number is 12, and we know we have 6 protons, so we could take 12 minus 6, and we could know that that equals 6 also. For the second one, how many protons and neutrons are in the second isotope? Protons, again, it's just going to be 6 because we always have 6 protons if we're talking about carbon. Neutrons is going to be a different number here because our atomic mass is different. Atomic mass is protons plus neutrons, so we can take 6 plus what to equal 13. So 13 minus 6 equals 7. Okay. And then for the last one, how many protons and neutrons do we have? Protons again equals 6. Neutrons is going to equal 14 minus 6, which is 8. Okay, so that part you should have filled out. Let's do the first part of the chart together as well. Complete the following chart. So we're looking at uranium here. Uranium, if we see on the periodic table, it is actually number 92. And when it says its isotope name, when it has it denoted like this, that means that it's atomic number 92, the name of the element is uranium, and 235 is the mass number. So the number of protons plus the number of neutrons together. So its atomic number is 92. Its mass is 235. That's denoted after its name. Remember, the atomic number and the number of protons are always the same. Remember, the number of protons and the number of electrons are the same. So I'm going to scoot down here to the number of electrons and see that that also equals 92. And then to find the number of neutrons, I take 235 and I subtract 92 from that because protons plus neutrons equals the mass number. So 235 minus 92 is, let's see, 143? Is that right? Yep, I think 143 is the number that I'm looking for there. Of course, if you have your calculator out, you can correct me because I just did that right off the top of my head and I can't know for sure if I'm 100% accurate at this time. Okay, to do the next one, we would look at the same thing. The only thing that would be different is our mass number is different because that's the second number here, and that the number of neutrons is going to be different. To do that, we would take our new mass number minus the number of protons, which is still 92. Let's see, we have 92 here, and that would give us our new number of neutrons. Okay, let's do boron together. To do boron, again, this first number tells us its atomic number, which is 5. Its mass number is the number after the hyphen, which is 10. The number of protons, well, that's the same as its atomic number, so 5. The number of electrons, the same as its number of protons, so 5. And the number of neutrons, that's going to be 10 minus 5, because remember we have protons plus neutrons to equal the mass number, so 5. Okay. This is one of those times when the protons, neutrons, and electrons are all equal to each other, but that doesn't always happen. Okay, let's take a look at this one here. We're going to do this chart, right? For this chart, we can complete the following table using the element chromium for this side and then the element carbon for this side. So it's a 2-part table. We're going to do the first part together, and then you'll do the second part on your own, and then the second page is the same thing using a different element, the element Na, the element Se, and then this one, instead of giving you the name of the element, I tell you how many protons it has. Remember, if I give you the number of protons that something has, or the number of electrons that something has, you can determine where on the periodic table it is, because the number of protons is the same as the number on the corner of the periodic table. Okay, so let's take a look up here. Back on this first page here with chromium. Chromium, it says number, oh, you want to know what? I don't have my periodic table in front of me right now, so I only have the top number, and the top number tells me what its atomic mass is. So I'm going to have to find a periodic table here so that I can fill out the top part. So I'm going to go to Google. I'm going to just click on this first periodic table image and see what I can see. And let's see, what was I looking for? I was looking for chromium, which is Cr. So over here, chromium, Cr. I can see that it's number 24 and its atomic mass is somewhere in the neighborhood of about 52. Okay, so chromium was number, what did I say, 24? Chromium is number 24, so its number of protons is 24. Its number of electrons, so I'm skipping neutrons for now, is the same as protons, so that is also 24. If I come back up here for the number of neutrons, remember that's where this atomic mass comes into play. I can take the atomic mass, which is 58, minus 24 in order to get my answer. And we know that 58 minus 24 is 34. So my atomic, or my number of neutrons is 34. Okay. My atomic number, that's the same place that I get my protons, so 24. My mass number is the number that they give us at the top, 58. Total positive charge. Remember, protons are positive, so our positive charge is plus 24 because I have 24 protons that are all giving positive charges. For number of negative charges, well, electrons are the ones that are negative, and I also have 24 electrons. So minus 24 is going to be my answer here. And then the sum of the charges. For our purposes, unless otherwise noted, the sum of our charges is always going to be 0, at least for now. A little bit later, we'll start talking about what happens when we have more protons than we do electrons, or when we have more electrons than we do protons. But for now, our sum of the charge is going to be 0 because we'll have the same number of positive protons and negative electrons to balance each other out. Okay? Okay. Then you would do the same thing over here with chromium 63, except keep in mind that the atomic mass, the mass number is 63 instead of 58. So that will change some of the boxes on your chart. Okay. Okay. These charts are all essentially the same thing. For the isotopic notation down here on number 4, what it's asking you is it's asking you to write it like this. So what you'll do is you'll take the symbol for the element and write that off to the side. And then to the left of it, you're going to write 2 numbers, kind of like a fraction, only without the bar in between. On the top, you're going to write the mass number, so the number of neutrons plus the number of protons. And on the bottom, you're just going to write the number of protons that it has, or what its atomic number is, where you can find it on the periodic table. So if we look down here, the number that's after the hyphen, that's going to tell us what its atomic mass is. So that's going to be the top number in your fraction next to the symbol. And then for the bottom number in the fraction next to your symbol, you're just going to use whatever number is on the periodic table for that element. Okay? Okay. If you have any questions, please make sure that sometime before this is due tomorrow at the beginning of class, you find me either before school, you can find me in the tutoring room 6th hour. Any of the tutors at any time of the day would be able to help you with this, or shoot me an email and I should be around tonight to answer your questions. But this is due tomorrow at the beginning of class, so make sure that you're ready to turn it in then, okay? Have a great night and I will see you tomorrow.